This is Bob Capetta from the College of the Florida Keys, and this lesson is on arithmetic series. So what does that mean? If I have something like 1 plus 3 plus 5 plus 7 plus 9 plus 11. This is a sum of 6 terms, and there is a common difference between each term. 1 to 3 is up 2, 3 to 5 is up 2, 5 to 7 is up 2, 7 to 9 is up 2, 9 to 11 is up 2. When there is a common difference, in this case the common difference is 2. So our common difference here is 2. And it's constant all the way across the board. When that happens, our series or our sequence is arithmetic. Now, let's see if we can figure out a way to describe this arithmetic series. It is a sum. Normally speaking, I like my sums to start at 1. So I'm going to say k equals 1 to somewhere. And my common difference is 2, so it'll be 2k. But you'll notice my first term is 1. 2 times 1 is 2. How do I turn a 2 into a 1? I have to subtract 1. So if I want to express this in summation form, this is the sum as k goes from 1 to what? 1, 2, 3, 4, 5, 6. K goes from 1 to 6 of 2k minus 1 would be that. Now, can we determine the sum? Well, we certainly could add all these together, but there's a nice little strategy we can use, namely looking at the first and the last term. 1 plus 11 is 12. 3 plus 9 is 12. 5 plus 7 is 12. So the first and last term, when we add those together, that's the same as adding the second and second to last term. It's the same as adding the third and the third to last term. That is going to be a standard concept for us with arithmetic series. So how do we do that? What is this going to equal? Well, I have a total of 6 numbers or 3 pairs times what is each pair worth? Each pair is 1 plus 11. Each pair is 12. So the sum becomes 3 times 12, which is 36. So that's a way for us to add all of these numbers to see how they are behaving. So let's take a look at another one. This time I'm going to start with a summation notation. Let's take the sum as k goes from 1 to 100 of 3k plus 2. Now again, this is supposed to be an arithmetic series, so I should see a common difference across the board as I do my analysis. So let's see what we have. Plug in values for k, and let's see what 3k plus 2 is. If I plug in a k of 1, 3k plus 2 is 3 times 1 plus 2, which is 5. If I plug in a k of 2, I get 3 times 2 plus 2, which is 8. If I plug in a k of 3, 3 times 3 plus 2, 9 plus 2 is 11. Plug in a k of 4, 3 times 4 plus 2, 12 plus 2 is 14. If I plug in 100, 3 times 100 is 300 plus 2 is 302, and if I plug in 99, just to see how that works, 3 times 99 plus 2 gives me 299. So I want to add all of these together. So this is 5 plus 8 plus 11 plus 14 plus dot 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 plus 209 plus 302. So we have a total of 100 numbers in the list. But if I add my first and last number, 299, excuse me. 5 plus 302 is 307. 299 plus 8 is 307. The one before this would be what? Would be 296. 296 plus 11 is 397. So we can see that the first plus last part all adds up to 307. So how many pairs do I have? There's 100 numbers in our list. So how many pairs would I have? 100 divided by 2 pairs times what is each pair worth? Each pair is 5 plus 302, first plus last. So what do we get? We get 100 divided by 2 is 50 times 5 plus 302 is 307. Then we multiply those together. 50 times 307 gives me 15,350. All right. So let's go ahead and try another one. So this time we want to have 21 plus 27 plus 33 plus 39 plus dot dot dot. How far are we going to go? Let's go to 177. So plus 171 plus 177. So we want to check to make sure that this really is an arithmetic series. So is there a common difference that maintains itself throughout? 21 to 27 is up 6. 27 to 33 is up 6. 33 to 39 is up 6. 171 to 177 is up 6. Now I like to express this in summation notation if I can, so I get a feel for how far out this goes. So our common difference is 6, so I'm going to start with, I like to start at k equals 1, of 6k plus or minus something. Now, when k equals 1, I'm supposed to get 21. 6 times 1 is 6. So how do I get to 21? I'd have to go 6 times 1 plus 15 equals 6 plus 15, which is 21, which makes me think then, to get to 21, I need to add 15 to my 6k. Now let's check to make sure that's right. 6 times 1 is 6, plus 15 is 21. 6 times 2 is 12, plus 15 is 27. 6 times 3 is 18, plus 15 is 33. That looks good. Now how far is this going? This is going to 177, so what is my highest value for k? Well, to answer that, I'm going to solve the equation. 6k plus 15 equals 177. 6k plus 15 equals 177. Let's go ahead and let's subtract 15 from both sides. Subtract 15. Subtract 15. And I get 6k is 177 minus 15, which gives me 162. And then let's divide by 6. And what does that give me? 162 divided by 6, I get a k of 27. So that tells me that the sum goes from k equals 1 to k equals 27. So that's where we are. We want the sum as k goes from 1 to 27 of 6k plus 15. So how are we going to do that? Well, sum k goes from 1 to 27 of 6k 15 is how many pairs? Well, there are 27 numbers in the list, which is an odd number. So we don't have an exact number of pairs. We have 27 divided by 2 pairs. Or if you like, we have 13 and a half pairs. The number that is directly in the middle will be the same as half of the pair. Now, what is each pair? Each pair equals 21 plus 177, which is how much? 21 plus 177 is 198. Each pair is 198. So what is my sum going to be? The sum, as k goes from 1 to 27, of 6k plus 15 will be 27 halves times 198. That's how many pairs we have. Each pair is 198. You multiply that out. 27 halves times 198 yields 2,673. All right. Let's go ahead and do one more of these arithmetic series. So this time I am going to say that A1 is 9, and a sub n plus 1 equals 13 plus a sub n. And we want to identify the sequence, and then we're going to add all the terms together. So our goal is going to be to find the sum of these. So goal, determine the sum as k goes from 1 to 40 of a sub k. That's our goal. We certainly don't want to list out all those terms. That would take an awful long time to do. But let's go ahead and find the first few to see how this behaves. So what do we have? If n is 1, what do we have? Our rule here is a sub n plus 1 equals 13 plus a sub n. That would be a sub 1 plus 1 is 13 plus a sub 1, which would tell me a sub 2 is 13 plus 9, which would tell me a sub 2 is 22. If n is 2, plugging in 2 for n, a sub 2 plus 1 is 13 plus a sub 2, which would tell me that a sub 3 is 13 plus a sub 2, which is what, 22, which tells me a sub 3 is 35. And let's do one more here at this point. So plugging in n of 3, a sub 3 plus 1 is 13 plus a sub 3. A sub 3 plus 1 tells me a sub 4 is 13 plus a sub 3 is 35, which would tell me a sub 4 is 48. Now you see that this goes out all the way to 40. So I'm going to need to go ahead and figure out what that is. And we don't really have a good answer for that yet, do we? So what I'm going to want to do is I'm going to want to write these terms and figure out a way to express this in summation notation. So let's see where we are. What do I know so far? I know a sub 1 is 9. I know a sub 2 is 22. A sub 3 is 35. A sub 4 is 48. So again, we can see it goes up 13. 9 to 22 is up 13. 22 to 35 is up 13. 35 to 48 is up 13. So we have 9 plus 22 plus 35 plus 48 plus somewhere out here we have our 40th term. We want to find out what that is. But again, just to emphasize, our common ratio here is 13. 13 here, 13 here, 13 here. So we have 13 then as our common difference. So if we're looking at this, we're going to say when k equals 1, I have 13k plus or minus something. But when k is 1, 13 times 1 is 13. I need it to be 9. How do I go from 13 to 9? Subtract 4. 13 times 2 is 26, minus 4 is 22. 13 times 3 is 39, minus 4 is 35. And I'm going to my 40th term. If I go to my 40th term, what is a sub 40? A sub 40 will be 13 times 40 minus 4. 13 times 40 minus 4 gives me how much? Gives me 516. So now we know we have 40 numbers in our list, and we know it ends at 516. So right now we are at 9 plus 22 plus 35 plus 48 plus dot 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 plus 516. Now there's 40 numbers in our list, so I have 40 divided by 2, which equals 20 pairs. How much is each pair? Each pair is, the first number is 9, the last number is 516. So each pair is 9 plus 516. Each pair equals 9 plus 516, which gives me 525. Each pair is 525. So what is my total? What are we going to say? We'll say the sum as k goes from 1 to 40 of 13k minus 4 is 20 pairs times each pair is 525, which gives me a total of 10,500. And that will conclude this.